What is going on, people? Today we will be going over the Wireshark, the basics. It's not really part of the junior penetration testing path, but it is a tool that you guys should know as penetration tester or as any cybersecurity analyst. So let's go ahead and get started. I might be looking on the at the different direction just to look at my different monitor because that's where I'm recording the video at. But yeah, go ahead and get started. To get started, you just gotta, start the Wireshark, the basics. And once you start the machine, click on the start machine. It might take about 2 to 3 minutes to fire up the machine. Once it loads, you should get a split screen where you get to see the other virtual machine. But if you don't see, just scroll up and click on the show split view. Once you click on that, you should have the actual virtual machine uh, inside your web browser. So obviously I'm not gonna go and read every single thing detail word to word, but if there's a need for you to pause the video, just feel free to pause the video and catch up or read it at your own pace. But this is pretty much what the Wireshark is about. So which file is used to simulate the screenshot? This is already given. You just got to read it. What it says right here. There are two capture files given in the virtual machine, which is the exercise PCAP and the HTTP1 PCAP. So for PCAP, HTTP1 is to simulate the action shown in the screenshot, which is HTTP1 dot PCAP ng. And which file is used to answer the question? Man, is there a way we could like mute that or something? Cause I hate when this shit. I don't like the sound. I wish I could go to. I don't like the sound, man. Which file is used to answer the questions? This would be the exercise PCAP ng. Exercise PCAP ng. There we go. Music might be a little loud, but just bear with me. The second one would just be the tool overview, the use cases. Obviously, like you need to know how to use Wireshark. It detects some troubleshooting for network problems such as network load failure points and congestions. Detecting security anomalies such as rogue hosts, abnormal port usage, and suspicious traffic, and investigating and learning protocol details such as response codes and payload data. This is something that we should know. Wireshark is not intrusion detection system or IDS, or it's not even IPS, intrusion prevention system. It is just a tool where you just sniffing, sniffer, like a tool that sits right in between your network and kind of grabs the packets, so you get to kind of filter the packets and examine it yourself. So that's why it is a good idea to kind of learn about that. So for Wireshark GUI opens with a single all-in-one page, which helps user investigate the traffic in multiple ways. So we'll go ahead and start up the Wireshark. So once you start up the Wireshark, it should come up like this. We do have this part right here, where this is the toolbar. This right here is the toolbar. You already have the display here on the picture. This display filter. We have a display filter right here, and the recent files. So this is where recent files were opened. You can always double click right here to open any exercise or HTTP1. And when you scroll down right at the bottom, you should find the capture filter and available sniffing interfaces. And this is where you pick the interface where the Wireshark will be using to kind of filter and sniff the network. So loading PCAP files. So obviously the above picture shows the Wireshark MT interface. The only available information is the recently processed HTTP1 file. Let's load a file. Which to load the file for HTTP1, you just gotta double click on it. As soon as you double click on it, everything will just come up. So the main three things that you should know is as soon as you open that, this right here right on the top, right at the top, we have http1.pcapng. That would be the file name, and you should have that right here on the left side of at the bottom of the screen as well. And the main three panes that we see is this pane right here. This is the packet list, which has the list of the packets that has been captured with the Wireshark. And this right here is the packet detail. So if you click on packet number 2, it will give you the detail of this packet. And this right here on the right side is the packet byte. So let's say this right here, if I click on the Ethernet, I will show you the bytes that is according to that exact packet detail, respectively. So if I click on the right here Internet Protocol version, it will show you the byte that is associated with that. So these are the three names that you should always kind of focus on. Color and packets, along with quick packet information. Wireshark also colors packets in order of different conditions and the protocol to spot anomalies in protocols and captures. So to look at your coloring rules, all you have to do is just go to view, go to coloring rules, and then kind of gives you like for bad TCP it would be red, for any TCP reset or SCTP abort it will be in red. Now these are the coloring filters. You can always change it, reset it, however you want. You can always either import or export this filter right here. So it's always a good idea to just play around with it. Okay, and then for traffic sniffing, you can use a blue shark button right here to sniff the traffic, but you have to choose the network interface before you do that. And then as soon as it starts sniffing, to stop, you can just use stop capturing. This will turn red once you turn this on, but it's not gonna work because you don't have. Actually, I'm not even running it through sudo. We need a sudo permission to even run that. So let me go ahead and open that again. And right here it gives you see how it says ENS5. This is the interface they used and the package that they have been displaying and package that have caught. But in our case, it's not going to be the case because we have not chosen any interface yet. Merge PCAP for files. You can always merge two pickup files. So you just got to go to file and merge right here, and then pick another one, exercise, and then you just open it, and then it will merge. But make sure you have to save it before you open it. You know what I mean? And then so now just read through it. But now use the exercise.pcapng file to answer the questions. Let's go ahead and actually open our exercise pcapng. For our exercise, as you can see, you have the name here, you have the packet list, the packet details, and the bytes. And right here you have the packet number of packets, 58,620, which is a lot. It's so hard to kind of go one by one, so you gotta kind of know how to use it. So read the capture file comments. What is the flag? To look at the flag, to look at the comments, you can always click right here on this button right here. Will kind of takes you to the capture file properties where you have all the comments right here. Capture file comments, you have that as well. So you have to, let me go ahead and kind of make it bigger. And what is the flag? So if you scroll down, here you go, you have the flag here, TryHackMe Wireshark demo. Let's go ahead and copy it, Control C and Control V right here. Not working. Control V right here, or Command V actually if you're on Mac. What is the total number of packets? For the packets, I think it is 58,620. 58,620. And what is the hash value of the capture file with the SHA-256 or SHA-256? That would be in our comment section or in the property. So you're gonna scroll up, and here you go. The hash value for SHA-256 will be this part right here. You go ahead and just copy the value. So copy it and Control V it here. And we are pretty much done with task 1. And then we're on task 2. So for task 3, let's go ahead and close this part. Packet dissection is also known as protocol dissection, which investigates packet details by decoding available protocols and fields. Wireshark supports long list of protocols. So for packet details, you can this is our packet detail, and this is our packet bytes. You can click on a packet in the packet list pane to open its details. It's always good to know your TCP, the OSI model. The OSI model consists of 5 to 7 layers, which is 7 layers. So my trick to remember that is just please do not eat. Please do not throw sausage pizza away. That's 7 right there. So that's physical. Please is physical. Do is a data link layer. Not is on network layer. Throw is what does T stands for? I forgot. T is transport. I'm sorry. Transport layer. Sausage is session layer. Pizza is presentation. Please do not throw sausage pizza away. A is application layer. So that's a little trick that I have learned to just memorize and kind of know the OSI model. And what are they asking? So just know each time you click a detail, it will highlight the corresponding part in the packet bytes pane. So if I click on right here, it will give me the inside the packet detail. If I click on Internet Protocol version, you'll get the corresponding byte, packet byte. If I click right here, it will show you the corresponding. I can't even. I was gonna use my hand. Corresponding bytes right here. Let's have a closer view of detail pane. So this is pretty much what I just explained. Just knowing the frame for layer 1, the source, the MAC, that is physical data link. So right here, layer 2 would be just the data link. Layer 3 would be the IP. So that please do not. So this is the network layer. This is the protocol layer. And then we have the application layer here, which is the layer 5. So for exercise, use the exercise PCAP file to answer the questions. View packet number 38. So to look at 38, we just scroll down until we find 38, and then click on 38. There's another trick that we could go exactly to 38, but I think we just go about that later. So view markup languages. Which markup language is used under the HTTP protocol? For HTTP protocol, this is gonna be in the hypertext transfer protocol for HTTP. If you click over there and scroll down, right here, extensible markup language is what they have used for which markup language. Here you go. It's already answering the question by giving us kind of the hint markup language. So it would be extensible markup language. And what is the arrival date of the packet? You just gotta kind of scroll down and look where the arrival date was. Last modified, no date that was arrived. It would be May 13 of 2004, which is they want us to use the month, day, and year. So it's gonna be 05. May, what does it say? May 13th. So 13, 2004. Sheesh, that's a while ago. What is the TTL value? TT is time to live, I believe. So let's go ahead and scroll a little bit up. Actually, I don't know, I keep taking it. So TTL should be somewhere here. What is going on? I hate this. Maybe scroll up, maybe. It's not here. It's not here. So like I'm staring at it, but I'm just not really. Time since request. And that's not this one. Okay, it should be in our transmission control protocol. And TTL. It's not timestamps. Don't know why I'm not looking. I don't know. I don't know, for some reason I can't find it. Sorry. Timestamps can't be there. Times. Nope. Where in the hell is this? Time keep alive. Yeah, my brain is fried. I've been on this OSCP studying. What is the TTL value? The time to live value should be, where is it at? Time to live, TTL value, TTL. Let's be logical. Where should be the time to live? It should be in our. It should be in our Internet Protocol version. Wouldn't it be? Yes. What the hell's wrong with me? Time to live 47. Sorry about that. And what is the TCP payload size? The TCP payload size would be somewhere over here. We have the destination, the source, which is the IP address, and total length. It is 464. The size. Oh, what? Oh, this is total length, not. Sorry. What is the TCP payload size? The TCP payload size would be in our transmission protocol. TCP segment length 424 maybe. Yeah, right here it should be TCP segment length. And then what is the ETAG value, which is, I just looked at it. I remember looking at the ETAG value somewhere over. It's not here. I know it's not here as well. It's not here. It should be somewhere over here. Here we go. We have the ETAG. Let's go ahead and copy the value. Let's go ahead and copy the value. And we're just gonna paste it. 9A1. We'll have to kind of manually write it because I don't have a space to copy that. 35 4B 00. That should be it. Okay, that's perfect. And then what is our next one? Our next one is packet navigation. We have the packet numbers, as you can see right here. We have the packet numbers, and you can always choose by based on the packet number. If I click right here, it means I have chosen the packet number 52, and it will give you the packet details and the packet byte. This is a packet list. If you want to go to a specific packet number, all you have to do is you gotta go click go and go to packet, and you just type the packet number. So in our example, we have 58,620. So if I wanted to click the 58,619 packet, there was no way I was going to scroll all the way down for 58,000 packets through 58,000 packets. So all I have to do is 58,619. If I click, I'm not sure why it's not writing, but 58,619. If I click on that, boom, just like that, we have 58,619. So it's kind of another quick way of going to the packet. So just know how to get there. Finding a packet. If you're trying to find a packet, another trick would be you just got to go to view. Not view. Edit and find packet. As soon as you find packet, usually the thing we will be using will be string or regex or regular expressions. So most likely it will be string, and then you just write your string. For instance, I would say hello or txt or anything that you are trying to find in the list of the packet, and you'll find it right here. You click on it and it will try to find it. So just remember, you got to go to edit and find packet is the little trick. To mark a packet, let's say I wanted to go back and work on this right here. I just gotta right click on it, and then you can mark it or unmark it. On the other trick is you click on the packet, you go to edit, and you can mark it or unmark it right here. And then for packet comments, all you have to do is click on the packet, right click on it, and then put packet comments right here, and then I could just put demo test, and I save it. This is, remember, 58,615. So let's click on 614, and when I go back to 600 for 58,615, you will have the packet comment that I just put. If you click on it right here, I just put demo test, which was just written by me. You can always delete that as well. You just gotta go click pocket comments and then just delete it, and then OK. So if I click 14, go back to 15, the packet is a comment is gone. And export packet, to export packet, all you have to do is just click on it, right click. Actually, I lied. Sorry. You gotta go to file and then export. You can export the sections or specified packet, or you can just export the object as in the TFTP, DICOM, or the HTTP file. That is pretty much it. Or you can actually, that is for to export the object. To export the specified packet or the sections, you can export it as plain text, that's CSV, or arrays, but I have no intention of doing that. For us, if you click on export and then export objects, and if you click HTTP, it will kind of show you the HTTP file that you probably should focus on. Time display format, you can always kind of change it up, because right now the way it is set up, I don't even think, do we have time here the way it's so I will kind of display view is very small, so I don't think we have time, but you can always go to your view and then go to your time display format, and then choose your, because right now we have seconds since beginning of capture, but you can choose that with the UTC with the date time of the day. If you click on that, now we have the 2004 518, and you have like exactly like the date and the time. This will be the default time display format, which was our previous one, and then now we have the UTC time display format. For the expert information, Wireshark also detects specific states of protocols to help uh, analysts easily spot possible anomalies and problems. For just chart information, it will be marked as blue, and information on usual workflow. Um, for notes, it would be this like whitish blue. I think it's called. I don't know how to pronounce that. Cyan. And then for warning, it would be yellow. For error, it would be red. And that is the coloring for our, expert information. Frequently encountered information groups are listed in the table below. You can refer to Wireshark's official documentation for more information on the expert information entries. We have the checksum, the comments, the deprecated, malformed. We don't really need all that right now to answer, especially to answer these questions. So use the exercise PCAP NG's file to answer the questions. I think we are already in the exercise PCAP. So let's go ahead and search the R4W string and packet details. To do that, as I explained earlier, you got to go find and then find packet. I was already on find packet. Let's go ahead and rerun it again. Once you have that find packet, let's go ahead and run R4W and then find. When you click on find, it will find R4W, and it found it on the packet number 37,061, and it is right here. If you scroll to your left or to your right, alrighty. Where to go? I'm gonna find it again. Right here. Artist R4W8173. It has already found it. Search the R4W string and packet details. What's the name of the artist one? Which is this artist right here, because it already has artist. The column for R4W. So in our case, we go ahead and finish it with R4W8173. Click on it, go to packet 12. So to go to packet 12, we already at 43,362 packets. So it's just gonna take a while if you're trying to scroll all the way up. So what you would do is you just go to packet, and then you just type 4, and then I don't know why it's not freaking typing, but 4, go to packet, and it takes you to packet number 4. Okay, sorry, they want us to go to packet 12. What am I doing? Go to packet 12. Here you go, packet 12, and read the packet comments. What's the answer? Okay, so if you click on 12, I don't think we have any comment here. 11, 12. There you go. Okay, 12, it does have a comment. Let's go ahead and double click it, and it will give you the comments here. And what is it saying? It's not telling us the whole thing. I feel like it's cut off here. It's not over yet. So let's go ahead and close that again, and click right here in the comment. Open the capture file property dialog, where you can find, the file comments will be here, especially the packet comments. We want the packet comments, not the file comments. So now for frame 12, right here for packet 12, read the packet comments, not the file comments. For the packet comments, we have this is not a flag, this is not a flag. Go to packet number 39,765. Just remember that. Let me just copy it anyways. And then look at the packet details pane. Right click on the JPG section and export packet bytes. This is an alternative way of extracting data from a capture file. What is the MDF 5 hash value of the extracted image? So they want us to go to file packet 39,765. Right click on the JPEG section and then export the packet. So let's go ahead and go to go to packet, and then control V it. Am I tripping? Control V to go to packet. As soon as you click on the packet, you want us to click on that, right click on it, and export packet bytes. That's what they want us to do. And then in your desktop, you just put maybe packets. I don't know. I'll just save it as bytes or some shit. Bytes txt. And then you save it. So go to your where are we? We're at Ubuntu. Let's go to our desktop. I think we saved it at our desktop. If you ls, you will find the bytes.txt. So we will do md5 sum bytes.txt. The hash value of the bytes.txt file would be this part right here. Let's go ahead and copy that. And if we okay, that's good. And then the other one, there's a .txt file inside the capture file. Find the file and read it. What is the alien's name? Okay, so they want us to find a .txt file inside the capture file. To find a file of, inside a packet, you have to click on edit and find packet. Once you have that, you can always write your string here. They want us to find .txt file. Let's go ahead and find .txt file. The first thing we found is this right here, which is notes.txt. If I click on the hypertext protocol, matter of fact, if I click right here and let's see, if I follow, find a file and read it. Alright, so let's find a file that is called note.txt. So if I maybe export packet bytes, I don't think this will work. I doubt this will work. Let's say notes.txt. I really doubt. I really doubt if it will work. CD to desktop. We have notes. If I do cats notes, yeah, it's not it. We actually have to kind of find the raw data file. So instead of doing that, I'll just go ahead and click right here, and then I will follow the HTTP stream to find the actual file. Nope. The other option I have is to go over there, file, export object, and HTTP, because it is an HTTP file. And then look for notes.txt. Notes.txt. If you click on that right here, text plain, you find the note.txt. So you can save that note.txt, and I can save it as note1 maybe, or one note.txt. Let's save it in desktop and save it. I renamed it because I already saved notes.txt earlier, even though it's not the right file. So we can close this part, rerun our terminal, and let's go CD to desktop, and we have one note. If we cat one note, we do find the file, and this is the alien. Sorry, this is the alien's name. So let's go ahead and zoom out because you could barely see. Zoom out. I'm gonna go ahead and zoom out again. I'm gonna go ahead and zoom out one more time and one more time. And if I can make this whole thing a little bigger, we have the alien name as Packet Master. Packet Master. Packet Master should be fine. And I'm gonna just close this one out. We don't need it. Look at the expert info section. What is the number of warnings? So if we go to export, the export information would be in our analyze and export information. If you export it, you have our comments, and then what is the number of warnings. So if you click on warning right here, And if I scroll this right here, the count, it is 1636 right here. Let's go ahead and click 1636. Should be our warning. That is good. Task 5, it is packet filtering. So for packet filtering, Wireshark has a powerful filter engine that helps analysts to narrow down the traffic and focus on the event of interest. So I will let you guys read this through to apply as a filter. So let's say if I am actually, let me close this out, and I am on my pocket, right? So if I go to, let's just go to pocket 1 or pocket 2 right here, pocket 1 and 2. If I wanted to use this or this part right here, you see how I'm clicking at the internet protocol version. If I want to use this as filter, I just gotta right click on it and use it, apply as filter, and then I could do selected, and it would just select this IP address only to filter and find anything that is coming from this IP, just by IP address only. If I click right here and from the Ethernet, use it as apply as filter and select it, I would just use anything that is coming from the ETH. That's pretty much the idea. Like, you can always click on a specific packet and use it as a filter, or inside the packet details you can use either the transmission control protocol. If they're using port, based on the port, they can right click on it and apply it as filter. If I put selected, it will use the port number 80, so it will filter anything that is related to port 80. And that's pretty much what the idea is. And right here you will get displayed 29,000 out of those 58,000, so half of it was just going through port 80. For conversation filter, you do the same thing. You can right click on a pocket, and then conversation filter. You can use your filter with the IPv4, TCP, anything that has to do with conversation wise, and then it will kind of give you the filter where you have the IP address and then the TCP port that has to do with these two right here, and you only have 34, which is 0.1% of the whole thing. So you kind of, like, it's good to know the filters and the in and out. Colorized conversations, you can always view colorized conversation and reset it as well. It's kind of good to know, so it wouldn't hurt. If you prepare as filter, this option helps analysts create display filter using the right click menu. However, unlike the previous one, this model does not apply the filters after the choice. It adds the required query to the pane and waits for the execution command, which is or enter, or another chosen filtering option by using the and or from the right click menu right here, and then apply it as column. By default, the packet list pane provides basic information, so you can always click right here and apply as column. If I apply it as column, it would add it right here in our column. Where is it at? It's gonna be on the right side, but we don't have any space to right here. We don't have any space, but that's kind of what the idea is. It's supposed to bring it right here as type, actually. But anyways, we're not really worried about that right now. We can follow the stream. To follow stream, let me go ahead and close this. I don't want it, and then you just click on it and you follow the stream, and you can follow the TCP stream, and it gives you it get to analyze the request and the response, and especially right here, streams are shown in a separate dialog box. Packets originating from the server are highlighted with blue, which is this right here, and those originating from the client are highlighted with red right here. This is the client requesting to connect And especially it is good to know if you have anything that is not encrypted, you can always get to read it with the especially with the HTTP protocol if you following the HTTP follow stream. Okay, so now to answer the questions, use the exercise.pcapng, which is what we have opened up already. Go to packet number 4. We don't have to go right here and go to packet because we already at number 4. We are gonna close this one out and make sure that we are showing everything is from packet 58,000. Everything is displayed, which is 100%, just to check you're not applying any filters at the moment. So right click on the hypertext transfer protocol, which is hyper transfer protocol right here, and apply it as filter. Let's go ahead and apply it as filter and then select it right here, HTTP. And then what are they asking? Now look at the filter pane. What is the filter query? Which is right here. The filter query right here is HTTP. And that is what they are asking. What is the number of displayed packets? So for the displayed packet, out of those 58,620, I have displayed 1,089, which is 1.9%. 1,089. Whoa. And then go to packet number 33,790. What is going on with these random numbers? Let's go ahead and close this one out right now. I mean, when you not close it, but cancel that filter, and then go to packets, go to packet, and then you click that packet number. Sorry, I just control V it. Go to packet. Now it takes you to 33,790. And then follow the HTTP stream. Let's go ahead and actually right click on it, follow and HTTP stream. When you follow the HTTP stream, look carefully at the responses. So this right here is the server response, and this right here is the client request. My shoulder hurts. What are they asking? Look at the web service response. What is the total number of artists? If I look for artist here, artist, we do have artists.php. And if I go next, we have another artist. Next, we have artist.php. Artists, find next, artist. We should have artist 1 or artist 2 or anything like that. Artists, artist.php, artists. I'm not sure. My Siri is picking up my voice. Artist. Okay, hold on. How can I go back? I found artist 2. Okay, we have artist equal 3. I've seen artist equal 2 right here. And then artist equal 1 right here. So we have artist equal 1, artist equal 2, artist equal 3. Do we have artist equal 4? Let's see, artist equal 1. Right here we do have artist equal 1, artist equal 2. Okay, we do have artist equal 2, artist equal 3. We do have artist equal 3, and artist equal 4. We don't have artist equal 4, so most likely it is just 3 artists. And so another way of doing it is what is the file right here? So right here I'll just say 3 and try it. It is 3, but another option would just be to hypertext transfer protocol. We looking for HTTP, so we can go ahead and actually we can not follow, maybe export the packet byte. And if I click artist and save it, then click right here and see the desktop, illicit. Do we have artist here? Artist, yeah. If we do cat artist, that's not what I want. GZ chunks. I'm messing up. Look for show packet bytes. No, sorry. We following the TCP stream. Once you follow it, we looking for artists. Our artists are in the artist.psp file. There should be another way of finding it. If I save it, maybe if I save this as artist1 and save it, and if I close it and I open the back up again and cat artist one, what? Oh, no, this is not it. It's not what I want. Let's say I grab artist. All right, that's what we want. We do have artist. Nah, this is not it. I mean, we already found an answer for it. I just wanted to find another way of doing it, but let's go. What do we do? Follow TCP stream. Let's go click on artist. Artist equal. What's the next question? What's the name of the second artist? Okay, so it would be artist equal to. And if I find next, it's not coming up. Oh, it just came up earlier. Come on now. If I click on artist, next, it came up earlier. I have no idea. It was just on earlier, like a few minutes ago. I have no idea why it's not coming up anymore. But there has to be a different way, because I figured it out earlier. Let's go ahead and close it again. What do they want us to do again? Follow the HTTP stream. Okay, let's click on it. Follow HTTP stream. And then artist. Right here, artist. Find next. 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 Oh, I see. If I do artist equal to, it should come up right here. Artist 2, which is artist 2 is in Blade, which is BLAD 3. Blade. The only reason that is working right now is make sure you're not clicking right here and following the stream. Make sure you actually clicking on the actual packet when you follow the stream. Because if you click right here on the hypertext transfer protocol and you follow the link, you follow the HTTP stream, you are not gonna find artist 2. As you can see right here, what the hell? You can actually find it. I don't know, guys. I'm just confused right now, because you were not supposed to find it, because I didn't find it earlier. No, not TCP. Come on now. Maybe I did TCP. Like, I might just go back and watch the video and see where I kind of messed up. But if I do artist 2, yeah, you can find artist 2 on both here and here. It should have been the same anyways, because you're just following the HTTP protocol. Anyways, it's working right now, but there was another way. I'm gonna just go back and check what I did earlier, just to make sure that I'm doing it correctly. But I know you have to go ahead and file it export objects, and then HTTP. And then once you HTTP it, you are looking for artist. So you have the artist.php. You go ahead and save it, and then put our artist PHP, and then look for desktop. Save it there. Save it in the desktop. Close it here. Open this part right here. CD desktop to it. Look for artist.php. Cat artist.php. What? And then once you have that, you grab artist, and then you look for you see how we have artist. We have artist 1, we have artist 2, we have artist 3, and then you have the corresponding names, which is for artist 2. Where artist 2 at? Right here. It would be Blade right here. And for our conclusion, congratulations, you just finished the Wireshark, the basics room. In this room we cover the Wireshark, what it is, how it operates, and how to use to investigate the traffic captures. To learn more, we will do Wireshark packet operations that I will be posting probably next week. But today it is a good work, so let's go ahead and proceed to the next room. We got this, baby. I'll talk to y'all later.